Right, so quotient identity for cotangent, she's even using the right term there, that would be like the group of identities. So that becomes cosine over sine. Alright, so that's one thing. And then the other part.
The second part, you can use the cofunction identity to simplify its sign.
Right, so that's a cofunction identity. And cofunctions happen for complementary angles. That's what that pi over 2 minus x is. They all have a co in them. So the cosine and the sine are cofunctions because they have complementary angles. So that just means that the sine of pi over 3 and the cosine of pi over 3, or I'm sorry, pi over 6 are the same. So if their angles are complementary, the values of them would be the same. But we can replace it with sine. So with the identities, after you replace an identity, you switch it, cancel the part out, do a little algebra, and then break it down into a single term. In most cases, it's going to get down to a single term, but we'll find today, once the problems get a little bigger, you're not necessarily going to get broken down to one function. You might still have two in the end. Any questions today? So Mackenzie, what about B? And then what about that cosine negative x? Yeah. So that is under the even odd properties or the negative angle property. And the book calls it one thing, and I think on there I had it the other because they mean the same thing. So even and odd functions go along with the negative angle identities. Cosine is even. That's why the cosine of a negative angle is equal to just the positive cosine. So that's the first thing you have to do. But then from here, tangent times cosine doesn't really mean anything yet. So Mackenzie, anything else? And then our cosines cancel and you end up with sine. That's really using three different identities. So cofunction identity, the negative angle or even and odd identity, and then finally the quotient identity. Little quiz tomorrow on those identities. Questions? Didn't give it yesterday, and I don't have it with me to give it to you today. I actually forgot about it. There are periods, so you guys got lucky if I forgot then.
Is it just on like the study sheet?
Yeah. Yep. So it's not like you're not simplifying. Literally, I will say, what is the reciprocal identity for sine? And you will say 1 over cosecant. So if you look at, Julian, was it number 11 that I was talking with you about?
Yeah.
Yeah. If you look at number 11, they give you the tangent is 7 over 24. So tangent is equal to 7 over 24. And your goal is to use the identities to find the other 6 trig functions. And it says if possible. And the other information it gives you is the fact that, it actually gives you 2 pieces. So it gives you the tangent being 7 over 24, and then it gives you the secant. For some reason I didn't write the other one down. So number 11, tangent is 7 over 24, and then the secant is negative 25 over 24. So you can find 2 functions without doing any work using reciprocals. Drew, if you know tangent, you can find which would become 24 over 7. And Drew, if you know the secant, you can find cosine, and that one is
24 over negative 25.
right. So using identities, we still need sine, and then once we know sine, we can find the cosecant. How can you find the sine using an identity?
Couldn't you use the quotient identity?
So you could take tangent and place it equal to sine over cosine. That would be one option, and then pretty much fill in what you know. So this is one way that you can find it because we know tangent and we know cosine. So just showing you what that would look like. Tangent is 7 over 24. We don't know sine, but we know cosine is 24 over 25 and it's negative. I'm going to place this over 1. So this would be one option. The reason I placed this over 1 was just so that we kind of had a fraction. And then like this is a complex fraction over here as well. So that would be one option. What other identity could you use, Ashley?
Sine squared plus cosine squared.
That would have been the other option. You're going to use one of the two. So no triangle, no just like guessing a random number, looking it up in the back of the book. It needs to be a true identity that you are using. Julia.
Does the Pythagorean identity of 1 plus cotangent square equals cosecant square work?
So you could also use this Pythagorean identity to get the cosecant if you wanted to do that as well. So there are a couple of options. It just depends on what you're trying to find. But we have negative 24 25ths here that you could plug in. Or you could plug in the cotangent, which is 24/7. But like one of those options you have to use and apply the identity. Questions on that? No? Are there other questions that you wanted to go over? The more we do these problems, they are going to get a little more involved. And they won't be quite as straightforward as like a single step or two. And we will build each day and try and kind of like just add a couple of things to the problem. So they're not always just going to be a quick plug in an identity and a simple cross off. Like there's going to be more algebra that we're going to have to do with them. So today we're going to wrap up this section, and tomorrow we're just going to kind of do some in-class practice. Today's homework will be a little more challenging. So these problems are ones that sometimes you're going to have to like restart. If it doesn't go anywhere for you, don't erase it. Just totally restart it again. Because you don't want to make the same mistake. So like if you erase, then you could possibly make the same mistake again. When I was in high school, I had my best friend's father as a teacher, which was like really weird because he was horrible. That's besides the point. Yes, he is that. I'm not saying that I'm great, but he was that. But we did identities for probably a month, and by the time we got done with them, one problem was 1 page. Like a full page was one problem. So like, I don't know, 10 to 15 steps. You'll have some that are probably 8 or 9 steps. But like most of the problems we did were in that 10 to 15 bubble, and we had like 5, and it took a long time to get to the answer. You will always know what the answer is either because it's in the back of the book or it tells you what you're supposed to get. And for today's homework, because a lot of them are even, I posted the answers onto Google Classroom so that you knew what to get to. And on the test, half of the test you'll know the answers, the other half you won't. So, but at least some of them you'll know what to work towards. In your packet, there's 2 more problems left in your packet for section 5.1. The first of those problems is definitely a little more interesting than the second 2. So trying to just go through different types. The goal is to show you different skills that you can use that we've learned this year in the pre-calc portion and how to apply it to the pre. But it really is like there's algebra embedded in these problems. So if you can't directly use an identity, we're going to try and see how you can use the algebra. But we don't do these for a month, and we won't get to like full page problems. Thank God. But we did a lot of trig. We didn't do a lot of pre-calc. I don't know why. He's not teaching anymore. So this one here says rewrite the following expression so that it is not in fractional form. So we're starting with a fraction. 1 over 1 plus sine x. And our goal is so that it's not in a fraction in the end. So once you get it out of fractional form, then you should be done with the problem. But all we have is 1 on top, and on the bottom 1 plus sine x. So the first thing you can try and think about, is there an identity that you can use that would help? That would get you somewhere. So that's the first thing. Can you use an identity? Like the 2 problems we just did as a warm-up. And don't write this down. But the only identity that you could use would be what? What's the sign equal to? If I was trying to use an identity. 1 over cosecant. That would be the only identity that you could try and use, because otherwise you got a 1. I mean, I guess you could change 1 into sine squared plus cosine squared. That would be something interesting to try. But if you try and use an identity and it makes the problem worse, meaning I have a fraction, now I have another fraction, that's going the wrong way. Just going backwards. You're making it more complicated, more involved than trying to work to the out of the fraction form. So that's not going to be an option. So if there's not an identity that you can use, then you have to try and think of algebra that you can try to do something with the problem. Ashley, you have an idea?
Can you square them?
Yes, how?
It would just be, you could just FOIL them or something.
You are on the right track.
Because you get sine squared.
Correct. So she's thinking if we have sine squared, we can do something with sine squared. You were 95% there. I think Kayla's going to help finish it. Do you remember what that's called? If you have 1 plus something and then you have 1 minus something, what are they called?
Is it a conjugate?
Yeah, they're conjugates. So Ashley, you were almost there. So when you had, and this was just on the review, if we had 2 minus I, the reason or the way we got rid of the I was to multiply it by its conjugate of 2 plus I. So the conjugate eliminates the I from the problem. So we're going to use conjugates here to help us eliminate the fraction. Ashley, I'll show you why the conjugate has to be used, because if we didn't use the conjugate, I'd still have a sign in there. Because if I multiply this by 1 plus sine, then I end up having a 2 sine. So that's why we have to use the conjugate. So the reason we use the conjugate is to try and get something that's squared, because then I have an identity that we can use. So we're going to multiply it by its opposite. Doing that also gets rid of that sign that's by itself, because remember, conjugates, the middle terms cancel. So on the top and the bottom, 1 minus sine. So conjugates, it's a great fact to use for multiple things. So we use it to help us factor things, we use it to deal with i's, we use it to rationalize fractions. So it's a good algebraic process that you can use. So the top now is 1 minus sine. And the bottom, when you FOIL, we end up 1 and then minus sine squared. Now, don't think ooh, these should cancel. Because I have a 1 on the top and a negative sign, I'm just going to make things cancel. Algebra doesn't work like that. So I can't just make these cancel. But instead, we need to use an identity. So, Kaylin, what identity would be similar to 1 minus sine squared? What identity contains a sine squared? So, we know that sine squared plus cosine squared is equal to 1. So, if we take this sine to the other side, cosine squared is 1 minus sine squared. So that identity, the Pythagorean identity, can be rearranged. They're called equivalent statements. So instead of having 1 minus sine squared, we're just going to take this out and replace it with cosine squared. So it's still a fraction, but the denominator is no longer 2 terms. So that means you've done something. You've at least taken the denominator, That was a 1 plus sign, and you've condensed that so that you have one term in the denominator, which is actually a good thing. One term is better than two. So now we have 1 minus sine divided by cosine squared. And there isn't an identity that we can use. We're going to have to try and do some algebra again. So it's usually going to go back and forth from an identity to a little bit of algebra, back to an identity, maybe back to algebra. And this part is a little weird because it's something that you usually don't do. And I'm going to tell you we're going to split this fraction up. So right now there are 2 terms now on the top of our fraction, but the bottom has 1 term. And when there's 1 term on the bottom, you can keep that as a common denominator, and we can separate the numerator. So this is now our common denominator. Usually we pull fractions together, but now we're going to do the opposite, and we're going to split the fraction apart. So the top is 1 with the common denominator, cosine squared. There's still a minus sign, and then the other top says sine x. These guys are the same. They're equivalent statements. It's just looking at that slightly differently. So looking at it as 2 separate fractions instead of 1 together. Why is that helpful? Like, where did that get you? Ashley? You can use identities. So you're doing an algebra, something algebraic, so then try and use an identity. And the first identity we can use is sitting right here. Ashley, what is 1 over cosine squared going to be equal to? Secant squared. That's a reciprocal identity. So now I have 1 term that's no longer in a fraction. Our goal is to still get that other side on the right side to not be a fraction. Ashley? You were close, but this isn't sine squared. So she's thinking that if this were sine squared over cosine squared, then it would be tangent squared. But they both have to be squared for that quotient identity to work. But we can do something similar with this cosine squared that we kind of did up above. We can separate it. So again, usually you're so used to combining things together, but instead sometimes you need to separate. If you have cosine squared or x squared, what does that really mean? What is x squared? Anna? X times x. So cosine squared really is cosine times cosine. So just separating it, and instead of thinking of it as cosine squared, really means I have x times x, or cosine times cosine. And then, Ashley, we can go back to you. What do you think you could do now, Ashley? This part right here can become tangent. And this, really there's a 1 sitting in front of that sign. That becomes the secant, because 1 over cosine is the secant. So, totally different way of thinking. Usually we say, let's get a common denominator, pull something together. X times x is x squared. You would never write it as x times x. But sometimes you need to undo things, separate things to get trig functions or identities to work. This, how many steps were there? 6, maybe 7. That's a more involved problem. And would you have thought to do all of that on your own? Maybe, maybe not. If you had enough time and a group of you to get your brains together, sure, maybe. But that would be a method to use. So like trying to think about separating a fraction. It only works when you have a single term in the denominator. So you can't have a plus sign. Like I couldn't separate this. I can't make it 1 over 1 and 1 over sine. So fractions, you can't split the denominator up. The denominator has to stay the same. But because there was just a cosine, one term, you're allowed to split the numerator. So numerators can be split, denominators cannot. So there's one final problem underneath. And this one tells you to verify. So big problem on the left side. two fractions instead of just one. Sine over 1 plus cosine, and then you're adding that to cosine over sine. It's equal to the cosecant. So if you're verifying, that's what our goal is. So you know the answer. So when it says verify, it's just saying, hey, this is the answer. You're not going to do anything with this. This is just your answer. And I don't want you to write it again. I don't want you to continually saying equals, 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 equals. I just want you to start with the left side and try and think, what can you do, maybe algebraically, especially if you have two fractions. Like algebraically, what do you usually do? So don't even do anything with that cosecant. Forget about it. That's your answer. So you know the answer. Try and think about how to get there. So I'm going to give you like maybe 2 minutes to see if you can figure out what you might want to try when you have fractions. You could probably say, well, cosine over sine is cotangent. You could change that to a cotangent, but I'm not sure that'll get you anywhere. But you got to try something. So you have to be willing to try something with these problems. And if you get to cosecant, then you have your answer. Just like the last one, if you get it out of a fraction, then you have your answer. Julian, what were you thinking with fractions? What were you going to say?
Could you find a common denominator?
That's probably a great step to start getting a common denominator. So when you have a plus and you get two fractions, usually you try and add them together. Anybody else try common denominators? Anybody else thought about that? Yes. Julia, what were you thinking? Nothing. Well, maybe yours isn't wrong though, because there's many ways to go through the problem. Yeah. Okay, that's good. No, that's okay. That works too. Like you're not wrong at all. Go see if you can get yours to go somewhere. So there's not necessarily one correct way to work through the problem. Sometimes there's 5 ways. So grading like a quiz on this or a test on this, there's really not an answer key because it's just me reading through your steps and seeing if you have a step that is equivalent from the previous. Julian, what would your least common denominator be?
Sine times 1 plus cosine.
Yeah, so the least common denominator, just the two pieces that are there, that becomes your least common denominator. So the one on the left has 1 plus cosine, it needs sine. The one on the right has sine, it needs 1 plus cosine. That's how a common denominator works. Essentially, you take the two denominators that are there, and you make sure that the left and the right have both pieces. So, Julian, what would the top of your fraction say with its with the tops being multiplied?
Sine squared, and then plus cosine times 1 plus cosine.
And if I said, let's just multiply that together too, might as well.
So cosine plus cosine squared.
Right. Okay, so using the common denominator, sine times sine on the left gives us sine squared. I just combined this as one fraction since right here I have my common denominators, and then just multiplying that through, cosine times cosine. Cosine times 1, cosine times cosine. That's the top. What would the bottom say? What would you do with the bottom? Ashley, did you do anything with the bottom? Okay, and what did you get when you distributed? So sine plus cosine sine. That's what you said, right? Okay. All right, so we did an algebra step. We used common denominators, multiplying by these common denominators. That's an algebra. Something you can do algebraically. Is there an identity that you can use now? So again, when you do an algebra step, look to see, is there an identity that would be applied somewhere in the problem? Hannah?
In the numerator, can't you make sine squared and cosine squared equal 1?
Yeah, does it matter that they're right not next to each other? No. Both of them are being added in the numerator somewhere. And the two of them combined is that identity that says they're equal to 1. So sine squared plus cosine squared is equal to 1. So that now is 1. They're gone. Sine squared and cosine are gone. It's just 1. But we still have this other cosine. And on the bottom, we have a sine, and then cosine, and sine. And we are almost done with this problem. So if you look in the denominator, what do you notice that they have in common? A sine. So if they have that in common, what could you do with it? Asher?
Factor it.
So if we pull it out, Asher, what would that make then?
Be sine times 1 plus cosine.
And if you do that, Asher, what do you notice?
The numerator and the denominator both have 1 plus cosine.
Right. So if you factor out the sine, because they both have a sine in common, right here's my sine, they have it in common. So these guys mean the same thing. By doing that, you can cancel out this whole 1 plus cosine, because it's exactly the same as the 1 plus cosine. So what's left on the top? A 1. The only part left on the bottom is a sine. What is 1 over sine? Cosecant. What were we trying to get it equal to? Cosecant. Now, Ashley, if you go back up to, yeah, so going back up here to this step here, we distributed sine to 1 plus cosine. Sometimes you don't have to do the distributing property. You don't have to multiply those, and that usually happens in the denominator. So you didn't have to distribute. Was it okay that we did? Yeah. We just kind of undid. Questions? Fun to problems, right? Tanner says, oh. So your homework tonight, it starts at 43, and it goes to 51 odd. Some of those problems are factoring, and the heading tells you to factor. And then after you factor, you'll have to try and simplify it. And then once you get to the even group of problems, which are like 60, 66, 70, those are the ones that are similar to these two problems that we just went over. So is anybody interested in doing, I know it's 62, okay, Drew 62, I'm trying to think of the other one. Let me look. I'll pick one that is good, I think it's 45 actually. 45. So this is what your homework looks like it starts with 43, and then it does say to factor. So make sure you factor it. Like in the directions, they're asking you to factor first. So make sure you factor first. So Ashley, 45 looks like this up here. Looks good. Don't worry about using a calculator. It says to use a graphing calculator. You don't have to use a calculator.